Welcome to this video series about building a Bomberman game in JavaScript. We're going to be using the canvas element and we're going to mainly focus on building a well-structured program. I have not planned anything except for the first episode yet, although there will be many more obviously. But the idea is to only plan one episode at a time. That way I'll make mistakes in how I structure the program, which is fine, which is perfect, and I'll just have to refactor them. Which is usually what you want to do when making your own game client or something, just any program really, because you don't want to try to think of the whole project, you just want to take one specific thing, build it and refactor, build it and refactor every time. And I'm hoping to teach you a way that you can use yourself to make projects and just build abstraction as you go along. So we're going to start off our project. I'll show you the sprites I'm going to use. I found these sprites on Envato. Well, these are the sprites. Some guy here, I'll put the link in the description where you can download the package. Pretty sure it's here. Yeah, you can grab the zip file and download it. We'll use these sprites because I'm awful at drawing, awful at animating, so we'll just take something from someone else, which is free. Okay. In Parcel.js, we're also going to use Parcel.js to compile our game client because we're going to use TypeScript. If you don't know what Parcel is, it's quite simple. It's a bundler. It will parse our TypeScript to JavaScript, minify it, and make sure that we can use it. It will also start up a local development server, which is quite useful because that way, that just makes it much easier for us to develop, as we don't have to do that ourselves. Now, if you don't have Parcel, just install it. Let me zoom that in. Okay. You can just install it using npm install -g parcel bundler, or with yarn, just install it globally. And all the other commands I'll just show in the video that you'll have to use. We're also going to split our project into a server and a client. And the top left and the top of the screen, you'll always be able to see which one I'm currently on. I'll try to remember saying which one I switch to, but sometimes I go a bit quicker than I plan. So the reason why we're splitting these is we're going to need a server that will handle our multiplayer and will serve our assets. The reason why we have to serve our assets is because we can't really put them in the client. The reason why we can't take them from our local drive when we're developing locally is because these assets are on our local file system, and we can't access our local file system from the browser for good reason. Like, you don't want any website to just access your local file system. That would be horrendous. So that's why we'll put them on the server and use them on the client. The reason why we don't use the game server to just handle the client, let's just say, to serve the client to the browser, is because we just want to keep them separate, so it's easier to think about the two different programs that are running in two different places. The client runs on the browser and the server runs in a node on a VPS somewhere as a node app. So we'll start with our game client. We're going to first set up a simple parcel setup. Obviously I chose Parcel because it's really easy to use, especially for these small projects. So we'll just init our npm. We'll create an index.html file where we'll put Bomberman as the title, and we'll add a single canvas element. Yeah, okay, we'll make a single canvas element, we'll add a width and a height. We'll use, whoa, I can't type today. And we'll use 720 as the height, which will be 720p by the way, for those who don't know, 16:9. We might change that in the future, we'll see. We'll start off with this one because it's quite general, it's a quite decent resolution to start off with. We're not going to make our canvas full screen, but will instead be a part of the screen. So our max size will be these values. We're also going to create a style.css file where we'll take our canvas and we'll limit the width to full browser width, and we'll limit the height to full browser height. We use VH because we can't use 100% in height. Oh, max height. What this will do basically, it will make sure that our canvas is always contained by the browser. So if you scale down your browser to a very small size, then you'll still be able to see the whole game instead of just seeing a cut-off part of it and having like a scroll bar or something, which is never good. So we'll also center it horizontally. We'll make it display block, and then margin left and margin right will be auto. Also give it a margin top of, let's say, 100 pixels, just so it doesn't touch the top. It's always nice if it like has a little bit of distance between the top and the actual canvas. We're also going to give the body and the canvas a background color. We'll change this eventually to be a bit prettier, but for now we'll just keep them like this. The reason why we do that is so we can actually see the canvas, otherwise the canvas will just be transparent. We can also just give the canvas a background. Actually, let's do that, so that we don't have to do anything there. Okay, we'll link that from here. We'll also create our source folder, which will actually contain our JavaScript code, and we'll make a game.ts file. Or ESLint will complain about it, no worries. We're just gonna also log something. Put in here, source game.ts, and then let's run parcel package.json. Create a dev script where we'll run parcel index.html, which will tell parcel to take our index.html, put it online, look for script tags and link tags, take the script tags and compile them from TypeScript to JavaScript, and run them on a local web server, which you'll see in a second. We'll also make a build command, which will be parcel build index.html. We'll need this eventually. What this will basically do is quite simple. It will just build the whole app into a static site, which we can just put up on any of the million static site hosting websites there are these days. There are a bazillion. So, and they're all free. Well, most of them are free. The good ones are free, let's just say. Okay, we'll try to run that. Dev. And it will run on 1234, which is usually the port that parcel takes. If it's in use, it will just suggest you a different port. So just look there to see where you have to go. So localhost 1234, and there we go. We have our canvas in the middle of our screen. And if you, as you can see, if we actually it makes it a bit harder to see. As you can see, if we make our screen smaller, we'll just stay within the bounds of our browser, which is great. Means our game is already responsive. An important thing to note, our width and height of the actual canvas, as in like the resolution of our game, will not change with when the actual canvas element changes in size. Meaning we just have to develop for this size and then forget about anything else. Forget about the actual browser interaction. Okay, let's actually draw something. So let's make a function run that function, get our element, canvas, if our canvas element is null. By the way, this is a big thing. This is exactly the same as saying typo. So it will check for null and undefined, which is really nice. So it's actually something you're one of the only places where you're allowed to use two equal signs, and it is best practice. in most scenarios. So that's what I'm going to use in the tutorial most of the time, so don't get confused when I do that. If our canvas element is null, oh shit, I want to type that. If it is null, just going to console log couldn't find the canvas element, and we're going to return. We're not going to run the game. So one thing I forgot, in our index.html, our script tag, we have to either place it at the bottom or put defer here, which will make sure the actual script doesn't get ran until the whole DOM has been loaded. Otherwise it will look for the canvas element and obviously not find it. So now we have to tell TypeScript what kind of element this is, because if you hover over it, we'll see that it's an HTML element, which is not right because we want it to be a canvas element. So we're just going to tell TypeScript that it's a canvas element. Or it's undefined. Oh, fuck off. Okay, or it's undefined. That way, we check whether it's undefined, and now we're absolutely certain that it's a canvas element. We could do this in another way by checking whether it has the right functions and so on, but we're pretty sure it's a canvas element and we don't really have to go further in depth. Like, we don't have to build something that's like useless. Okay, so we can assume that's a canvas element, and now let's make a context, which will be what we'll use to draw on the canvas. And we get that context by running canvas_l.getContext, passing in 2D, because it's going to be a 2D game. And now we can draw something. So we're going to say context.rectangle. Let's put it at 100, and make it a width of 200 and a height of 200. So it's x, y, width and height. Let's fill that rectangle so it's visible, and that should already give us a rectangle. As you can see, our rectangle gets drawn on the screen on our canvas. That's a good first step. That's exactly what we want as our first thing. Now the next thing that we need is an image. We're going to need to get an image in there. So to get that image, we're first going to use our server, set up our server quickly so it can actually serve that image. So let's init. We're going to use Express.js. We'll install that, create a source file, create a server.js file. In our package.json, we'll put a script, which is start node src server js. The reason why I always make a source file is because that means that the actual files are separate from the setup files, the config files such as package.json, package.log, environment variable, like whatever you want to put there, disk, config, ESLint, whatever. Okay, so oh my goodness. Import Express, create our app, set our port. Actually, we won't do that here. Then app.use express.static, I think. Pretty sure, yeah. I will make it public. We'll make a public folder which will have our assets in there. Oh, we have to. We'll also put that behind a static identifiers. That way it won't interfere with any of the other routes. I will make a route just to welcome people. Request response. Get our app to listen to port 4000. Free to change that however you want. And if it's running, we'll just console log running on port 4000. We'll put that port in a variable actually. There we go. We'll actually do one more thing. We'll say process.end.port for 4000, which will mean we'll actually take the port environment variable, or we'll take 4000, meaning in production we can actually that's better. In production we can get that to run properly. Okay, let's see if that runs. 4000. Welcome to the Bomberman game server. Now let's take one of our assets, which I don't currently have. One sec. Didn't have it open, but basically sprites. We'll take our blocks. We'll take the background tile, which we'll put here. I'm going to call it background.png, which should mean that bg.png. There we go. We can access that file. So that's how we're going to load our image. Now, in our game, we can use our context to draw an image. The first element of draw image is an actual image. So we'll have to get that actual image. In JavaScript, we can just say build a new image, which is an actual image element. As you can see, HTML image element. We can set the source of that image. We can set the source of that image to whatever, which will in this case be, copy that, our local server bg.png, and then we have an onload, which will take a callback function and image loaded. So what we're going to do is we're going to put this in a different function, because we want to be able to wait for it. We're going to make this async load image. I'm going to pass the URL as a string. Pass the URL in here, and once it's loaded, we'll return. So how we're going to do that? We're going to return a new promise, which means we don't have to make it async. We'll just return a promise, which will contain an HTML image element. In TypeScript, this just means we will return a promise, and that promise will return an HTML image element. Now, promise will take resolve, going into brackets, put this in there, put our source under our onload, because we don't want it to load instantly and then our own load doesn't get called. It's just best practice. And once it gets loaded, when it's done, we'll resolve with our image, meaning return from the promise the image. And then here we can either put that above, might complain otherwise. We'll say load image from URL, take the URL again, which I forgot, and then we can add a say then, or what we're actually going to do is make this one asynchronous and wait for it. And now you'll see that this is an HTML image element. So now we can draw that image to the canvas. So we'll say draw image or image. We want to place it at same position that we placed the other one, and we want it to have a side of 128, 128. So we can probably see it. When we open our server, we can see that an actual image gets drawn to the screen, which is exactly what we want. Now, we have our background image. Let's draw a map, which is a really great thing to do. So let's make a function draw map. It will take map image. Will it? Yeah, it will be an HTML image element. Tile image, let's call it, because it's a single tile. The whole thing is the map, and one of these things is one tile. So now we're going to need a few things first. So we're going to also need the width and the height. Yeah, those are the things we need. Because what we're going to do is, no matter which width or height the canvas has, like, I mean, the game has, we still want to fill the whole thing with tiles. So what we'll do is first get our tile size. We'll make it 64 pixels, which means width equals 64 and height equals 64. We know that the width and height are going to be the same size, so we just call it tile size instead of making two variables. Okay. Then we'll also need the tile count x, see how many tiles we have on the x-axis, which will be our width divided by our tile size, which is really basic math to just say divide them, see how many times this tile fits in the width. And we're going to +1 that. Also, in JavaScript we don't have integer division, so we're just going to mat.ceil that, and now we don't need to +1. Meaning, say for example, 10.5 tiles fit inside of the screen, then we'll take 11, because we don't want to see white space at the sides of the screen. We'll do the same for y with the height instead of the width, and now we can draw. So we're going to loop over all the rows, so we'll just go until we reach tile count x, then we'll add 1 to y and just go again until we have the full screen filled. So we're going to need 2 loops for that. Our first loop is going to be x, smaller than tile count x. Actually, our first loop needs to be y. Well, it doesn't really matter, like you can use both, but if I want to use the analogy that I just used, then it has to be y first. Set that to null if y is smaller than tile count y for x equals 0, x smaller than tile count x. Okay, and then here we'll draw the actual image. Take this one, put it here. We'll need our context as well, I've completely forgot. Annoying. What was it? Canvas rendering context. Now, I know this takes a lot of arguments, probably not a very great order, but we'll fix that in a second. We first need to get this to work. We'll put our tile image here, 100. This will be the x position, which will be x times the tile size, because it will be the, for example, the third from left, which means 3 times 64 to get the actual position that it has to start at. Same with y. I will make tile size the width and height as we said earlier, which will draw us a map. So now we have to just run that function with our context or image width we can get from the canvas element, and height we can also get from the canvas element. There we go, and our entire map is filled with grass. I mean, I hope you can see that, but it's just literally tiles everywhere. Like they don't overlap, they're clean, simple. That's how you do it. Okay. So now, we don't need these exactly just yet, but what I want to do is build a game loop. And in the same, right before that, I'm also going to restructure quite a bit of our actual game. So we're going to take some of our game, actually make a game.ts file. Can't do that yet. Make this bootstrap, which is going to be our file that bootstraps our game. We're going to make a game.ts file, which is going to be a class. Export that class. Oh. We will take a constructor with the context, which will be canvas rendering context 2D. We will take a width and the height, which will put it in variables, context, canvas rendering context 2D, width, okay, and then we'll have a run, which will be a public function, which will actually run the game. Take our function draw, we'll need our function draw map, put it here, make it private because we don't want to use it anywhere else. Gonna take these two things, make this one asynchronous. Oh. This.draw map will be this.context, this.width, this.height. We're going to change this function to bootstrap, just for semantics. Take this function, put it here, private load image from URL, and we'll read this.load image from URL. Get our game. Oh. We'll take context, canvas width, canvas height, and then game.run. And that will just have bootstrapped our game. And now we can actually go into OOP development because we have a game. Now let's see if our game still works. No, it doesn't. Go type of what? Huh. Type undefined. Where's that? Not sure what I did wrong. Oh yeah, that's fine. What did I do wrong? New game. Have a look. Nothing here. Great build error. Still. Let's restart our dev service, see if that works. Yeah, okay, it was just because we deleted some files and recreated them. Although our actual thing doesn't get ran, I'm pretty sure, because we have a blank screen. Let's open our console, nothing there. Let's see how far we get. I like to use console logs. You can use a debugger here, whatever you like. I know this is a big thing. I probably should use a debugger, but can't be honest with small things such as this. Nothing gets run. Wait, what? Okay, what? Oh, I know why. I'm retarded. Basically, in our index.html, we import game.ts. We don't want to import game.ts. We want to import bootstrap.ts now, and there we go. Because the bootstrap will start our whole application, let's just say. Okay, now we've refactored that, we can go into our game.ts, and we still have some issues, right? We have our load image from URL, which is something that our game class should not be responsible for. We have our draw map, which is definitely something our game class should not be responsible for. So let's first take our load image from URL and put that somewhere else. I'm going to make an image util class. Take that, take our function here, put it here, make it public static, because it doesn't actually affect our state anywhere, so we're just going to make it static. Makes it much easier. Now we can go image utils .load image from URL, and it imported it as well. Much cleaner already. Now our draw map has to go to a map function, because it's also not like drawing a map is a responsibility of our actual game, but it's not a responsibility of our game class. So we'll make a map.ts. Take this function, put it here. We're gonna need a few things. Some of these things we can just take in a constructor. We'll take the tile image. We'll take the width. I will just make it width and height, because we already know it's about the map, because this is the map class. What's wrong, by the way? What's from here? Oh, games map. We can't use map because it's reserved, which is fine, to be honest. I'll just call it game map. It's fine. So let's take these values in our constructor. Tile image. We'll take a width. I will take a height. Tile image equals tile image. We'll change draw map to render, because we already know it's this one. We don't need our tile image, we don't need our width, we don't need our height. And I don't know why I commented this out, but it doesn't have to be. Oh my goodness. Our width will now be this.width, this.height, and our tile image will be this.tile image. Everything still works. We'll make this public, obviously. And then we have our game map, which we still have to export. So now we'll create a map. Which will need take our image, our width, and our height, and we'll just say map.render context, this on context. Okay, and as you can see, it still works, which is exactly what we want. Now let's take a second character and we want to move that character along the screen. So what we're going to need now is a game loop. Let's build a game loop. For the game loop, by the way, short thing, we're going to use window.request animation frame. The reason we're going to use window.request animation frame is because it's just so much nicer these days to use. Like, the support is great. The only one that doesn't have support for it is Opera Mini, which you can see here. gonna use request animation frame. As you can see, Opera Mini doesn't have support, but really doesn't really have support for anything, and everyone really has good support. It will just ask the browser when it is ready to draw a new frame. It will just run that callback that we pass here. So what we're going to do is we're going to put a private loop function. At the end of our run, we're going to run that loop function. An important part is if we pass this.loop as a callback in JavaScript, it will not have access to the actual instance of the object, which is quite important that it does. So we'll bind the instance. Well, this will basically mean, okay, take this function, which if you run this function, this will refer to, in this case, this, so the instance of the object. Okay. So now we'll have a game loop. At the end of the game loop, we also have to request the animation frame. We can really do this at the beginning as well, but let's just do it at the end. It will basically just be waiting for the browser to tell us, okay, I'm ready to run the next frame. By default, the browser will have an FPS of 60. So we'll just be limited to 60 FPS. And now we'll take our map. Put this.map equals new map, and our render function can go here. It's not that important at the moment, but it will become important later when we have actual moving characters and so on. So we take our map and put it in the rendering loop. Okay, that should work still. Okay, great. Now, if you want to move something, let's actually just get the character. Char image. Let's put that in here. We'll change it eventually. These are both things that will eventually leave this place probably, because they don't feel right currently. This.char image equals await image utils .wait image from URL. I will put it in our server. Take our image, our Bomberman. Let's take the front, put it in here. Player front 0, 0. Yeah, let's keep it as that. Restart this server, and we should have access to that in. There we go. We have access to that. Let's go back to our game client. Put that URL here. We'll have this image, and then right after we draw the map, because it's like you draw the map and then you draw on top of it. So if we put it before the map, then the map will be drawn on top of our character. Sorry. Draw image. This.char image. And we'll say put it at 100 with a width of this. Actually, we'll just keep the whatever 64 by 64, which will look deformed as fuck, but we can actually just put it at 100. There we go. Now we have our player, who just stands there, and we want to move that player. So what we do is we give char x give our character an x and a y, and on every tick of the game we say this.char x plus equals 1, where that's 2, 3, whatever, that's your speed. So we can see that our character is moving. The issue we have here is quite big, and the issue we actually have is if our FPS changes, then our character will move faster or slower, which is not great at all. So this is not only when we change from 60 FPS to somewhere else, because we could easily limit to 60 FPS, but the issue becomes really big when we have when we're, for example, lagging, right? We put too much things on the screen and the FPS drops to 55 on some slower people's PC, or it drops to 30. If the FPS is 30, then the character will only move half as fast. So we need a value to times this, which will be how long it took since the last frame. Meaning, say for example, if we have 60 FPS, it will be about 17 milliseconds, 16, 17 milliseconds. If we then have 30 FPS, it will be double that, meaning that our character will still move the same pace. It will still move at the same pace. So, it will be, to calculate that value, we need a few things. Well, we need one thing really. We need a function which gets timestamp in milliseconds, turn new date, get time. Need that function, and I will need last time. When we run, last time has to be set to otherwise, and the reason why we do this, by the way, if we don't do this and we set it to 0, then the first time you will assume that the first frame was at 0, and 0 in a timestamp is like 1970, 1st of January 1970, so it will just move everything really far along, which we really don't want. So instead we'll just set that here, and then when our loop runs, we'll take current time, compare it to our last time, and that will be our delta. Our delta is the time since the last frame, by the way. Our delta will be current time minus this dot last time. And at the end of our frame, we'll say this dot last time equals current time. And we can actually just do that here, to be honest. Yeah, okay, and so now we have delta. We can times this by delta. What we'll also do is divide this by 1000. There we go. The reason why we divide this by 1000 is because otherwise it will be 16, 17, and we'll just have to divide it here. And that way it will be much easier to use. So our delta will be time since last frame in seconds. Okay, and now we can see, no matter which, let's make it a bit slower. No matter our FPS, it will still move at exactly the same pace. Okay, so now we're going to refactor quite a bit of this as well. So now we've made it something and we want to refactor it. So a few things that we want to do, like first of all, this loop with window.request animation frame, it could change. We don't want it to be part of our game class. So we're going to make a game loop. Right. Does it need anything? It needs one thing. And that will be, we're going to define a type for it in TypeScript. Will be a function which will take nothing and return nothing. Does it take? It takes a delta. Because the delta will be calculated in game loop. We'll actually start the loop and run it in this class, in an instance of this class. And we'll call a function in game.js that will get ran whenever an iteration comes around. So we'll need function, loop function, we'll just call it. We'll also need our actual loop, and we'll need the public run. I'll just call it start run. I'm not sure. We call this run, so we'll call that run as well. Which will take these two things. We'll set our last time. Okay, we need get timestamp. Set our last time, so we need a variable for that. We'll copy that from here. We need to set our last time and start our loop. Fucking hell. My voice is cracking. Okay, we'll take our delta calculation, put it in this loop. Take our other request animation frame and also put it in this loop. And now we basically have everything that we need. Don't need this anymore. And instead, we'll say export this first. Game loop, which will take a function, which will be this dot. I'm thinking whether I should oh yeah, I forgot something. This is our loop function. We actually call the loop function with delta, which will be this function. So we'll take this dot loop dot bind this, and we'll say game loop dot run. So we'll start running. This one will take a delta. And as you can see, our game class is much simpler, much easier, way easier to understand, and much shorter mainly, which is quite important. Okay, so we have our run, loop, get timestamp. Seems correct. Let's see if it still runs. There we go, still runs. Now one more thing I noticed, let's close our tabs. One more thing I noticed is our timing, like the delta calculations will be, like they don't really have to be part of the game loop, do they? They could be, but I'm still going to abstract them away. Just find it cleaner. Well, I think it's going to look cleaner. Okay, we have our delta tracker. This, call it get and update delta, return delta, and I will have private last time, which we'll just copy from here actually. Get timestamp. Delta, and our delta will be cons delta equals, oh, we'll have a delta tracker. So delta tracker equals new delta tracker. We'll also have an init function. Which will take this. This will delta tracker.init, and then this will delta tracker.get and update delta. What I'm actually going to do, if this dot last time equals null, just as it is here, then we're going to say this dot last time equals the get timestamp less. in which case delta will be 0. So we'll just say return 0 as our first delta. And then otherwise we'll just run all this. Now we don't need an init, which is another thing we don't have to think about, which is great. Loop function, blah blah blah. Okay, let's see. Still works great. And as you can see now, we got our game loop. It is much simpler and much easier to understand. Once again, we got our game, and our game is still way too big. The reason why it's too big is because it's still taking that character, drawing its image, and setting up a lot of the map and running that. We're actually going to, no, really. I was thinking of making a setup function, but we don't really need that. Okay, this is where I'm going to end this video. I'll put all the code up on GitHub, share the link in the description, and hopefully you will like the video. Let me know if there's anything you need clarification on. Let me know if there's any information you still need. In the next video, next episode of the series, I was thinking of abstracting this this character into a different class, and maybe we'll add some scenes. That seems like something. Like we'll add a start scene where you can just start the game, press play, and then we'll have an actual playing scene and so on, which will give us a place to put all these things, or rendering of the map and so on. So that will be fun, I think, and we'll do that. Okay, thanks for watching and have a great day.